Hello everyone, and welcome back to TechFlow Media. This is a part 3 of our comprehensive series on the Siemens Electrical Designer inside the TI selection tool. Let's do a quick recap for our last two videos. In part 1, we went over the high level overview, the core purposes of the tool, and the massive benefits it brings to your engineering workflow, right? And in part 2, we looked at to start fresh by creating a new project and navigating the main dashboard interface, right? So if you missed those, I highly recommend check them out first to follow along seamlessly, right? So today we are getting into the core configuration steps. Our main agenda is to create an infeed and explore all the available load feeders currently supported in the electrical designer. I'm going to show you exactly how many different electrical loads you can build right now, and how to set parameters in the infeed configurator for load feeder configurator, for electrical load configurator, and a device configurator. I will create different videos where I will explain each filter to filter very deeply, right? But today our agenda will be understand the only infeed filters and supported load only, right? So as you can see here, I have the portal open. I will quickly set up our project space here. If you need a slower walkthrough of these exact steps, definitely refer back to a part 2. Now look at the top menu. So let's see, I will just create new project here, and I just keep the name as a project only, and now I click on the electrical designer. So if you see here, the main electrical designer canvas got opened, and now if I click on the new IEC Infeed, if you see here, the new pop-up window, add new branch with this cross closing symbol got opened. Here you can see that there are some load names like motor load, frequency converter, resistive load, inductive load, power socket. So distribution element is also there, but you can see the distribution elements means it's not a load actually. So it allow you, it's allow you to split your main distribution circuits into the sub panels, right? So for a moment, let's click on the motor. So if you click on the cross button, then this pop-up will close, and just if you see in the background, this much SLD only will remain. But just for a moment, we will click on the motor because we want a load for the today's video. So just click on the motor load. So if you see here, you can see all the elements, how these beautiful SLD got created. If you see, the first element is infeed IEC, then second one is a line protector, then one cable symbol is there, and a distribution element is there, again two cable inside and outside of the cabinets, which is a part of the load feeder, and then this is our currently created load feeder we have created. So in upcoming videos, I'm planning to explain you element by element, right? These all the elements I will explain you one by one. What is the infeed IC, then line protector, how to configure it, and then this cable, how can we configure, and then load also, how can we configure. So all the configurator I will explain you one by one in every video. And once all the elements got covered, then I will, you know, we will create one complete project after you understand how to, how to set all the filters from each configurator. But today's video is our agenda is to understand how to configure the infeed, because this is the first element of this SLD, right? So let's click on here. Once you click on the IEC Infeed window will open, right? And you can see here from the top, we'll go one by one, so you'll understand very deeply. So Infeed IEC is our IEC name. If you want to change it, go to the properties, and let's see, currently you are working in India or Europe, so you are using IEC standard, so let's we will use 400. So just I will give a dummy name like for the demo purpose, Infeed 400 volt, right? So just click outside anywhere, and then if you see our, we renamed our Infeed name. You can give any name right here. So after that, if you see Infeed parameters, we have this much parameters in the Infeed section. That is our today's agenda, to understand each and every parameter, right? So the first parameter is standard for the electrical dimensioning, that is IEC, and it is a non-editable parameter. So it is by default parameter by the electrical designer, by the Siemens, and we cannot change. So it means that simply this project is following the IEC standard. That's it. You just you just consider like that. All the dimensioning, cable dimensioning, or all the devices that we are going to select, all these things are going to select by the IEC standard, that is the filter. So second parameter is system configuration. So here if you expand this combo box, TNS and TNC is we can see. So 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 where we have two options in the system configuration. So if you select the TNS, it means the neutral and the protective earth, that is a P lines, are kept completely separate throughout the entire distribution network. It means you required 5-wire system for a 3-phase power. For example, here 5 wires means L1, L2, L3, these are all 3-phase, and neutral and a separate dedicated wire for the earthing, that is a PE. So it means that in short 5 wires you required here. And if you select the TNS, TNC, sorry, that is the common. C means common. You just remember these things. So if you select the TNC, then it means the neutral N and protective earth P lines are kept common. It means you required 4 wire system for a 3-phase power, that is L1, L2, L3, neutral and earthing, that is a P will common, right? So it saves on a cable cost because you install one less cable, but it can cause small voltage to appear on the metal enclosure of your equipment. For this reason, it is heavily restricted in modern facilities which has sensitive electronic devices. For now, for this project, for the demo project, I'm going with the TNS. So just I will select the TNS, that is our first. Second, I can say the parameter we set, and then supply voltage. Let's see how many voltages are here. So 3 voltages options are given by the electrical designer. So generally 400, 500, 690. So accordingly your project's requirement, you just select. For a moment I will I will keep it as a 400 only. Frequency 50 and 60 hertz. So again according to your project need, you just select these options. Now this is the important part, I can say, short circuit behavior. So if you see here, the first filter is the method to describe the Infeed short circuit behavior. So if you expand it here, this filter is just to enable these 1, 2 and 3 filters. So as a user, if you want to edit it manually, let's see, if I want, this is a by default 30,000 ampere or 30 kilo ampere of the short circuit IK3 max. I will explain you what is IK3 max, IK1 max, IK3 mean, IK1 mean, but here I'm just explaining first filter, what exactly the purpose of this filter. So if I select the second one, IK3 max, then both the filters can be editable. If I select IK3 max, IK1 max and IK3 max, these all 3 filters will be the editable, so user can give the value manually. So that is the difference. So currently just I will keep only IK3 max. So I want to manually configure only IK3 max and let electrical designer will automatically calculate my IK1 max and IK3 max as per the standard. So so what is the IK3 max, right? So it is a maximum 3-phase short circuit current, the absolute highest current that will flow if a fault connects all 3 phases L1, L2 and L3 together with the zero resistance. So this value is usually to determine the braking capacity of your protective devices like MCCBs or circuit breakers or motor starter protectors, etc. Like for to selection of these protective devices, these values are very important. Your circuit breaker must have the braking capacity rating higher than the IK3 max, right? And next is IK1 max is the same, only it is the highest current that occurs during a direct short circuit between the single phase, whatever example L1 to neutral will if the fault will occur, or L2 to L2 and neutral, or L3 and neutral, means single phase line and the neutral or earth line right at the source terminal. If fault will occur, then that is the our maximum single phase circuit current, right? Short circuit current. So this value is used to determine the braking capacity of your protective devices which are a single phase, same as a three phase. So here in the above with IK3 max for the three phase short circuit maximum short circuit current, IK1 max is maximum single phase short circuit current, and next is IK3 min, that is a minimum three phase short circuit current. It is the lowest possible short circuit current expected during a three phase fault condition. So according to your industry standards, you can set this all the parameters, all the filters, these and in standard electrical plants I can see 22 kiloampere to 36 kiloampere is a baseline. So just according to that, I think by default 30,000 ampere is given. And don't confuse it here. So this all the units are in the ampere, so that's why it is a 30,000 ampere. And so you just consider it is a if your requirement is 30 kiloampere, means it is correct. So 30 kiloampere is nothing but the 30,000 ampere. So all these short circuit behavior parameter is selected. Now let's come to the maximum installation altitude. If you see here, by default 1000 maximum installation altitude in the meters got selected. And if you see here one note in the down, that they are mentioned electrical designer currently only supports installation altitude up to the 2000 meter. For installation altitude higher than 2000 meter, refer to this frequently asked article. So if I click here, then new tab will be open. So this installation altitude is very important because it will impact, it will create impact for your protection and switching devices. And maybe if you see here, all these information is given, but if the altitude is between the 2000 meter to 5000 meter, it means that above from the 2000 meter, then operating voltage of your system or operational current, motor current settings and short circuit breaking capacity must be reduced depending on the installation altitude. So it will directly impact to your all voltages, current and other motor current settings. So be careful, see your project location, where is your project location, and according to that you can just set the maximum installation altitude. So okay, so this I hope this infeed section is cleared for a moment. And if we'll go back again to the electrical designer, now we have finished this our first element called the infeed infeed configurator. Now we'll go one by one, but after the infeed we will jump to the down, that is a load, because load is important, and after that then we will plan how we can manage it. But in the next video we will see the motor load configurator. So if you click here, then we have this much loads here, but it's difficult to cover in single video. So in the next video I will explain you how to set the motor configurator. Once each and every elements configurator you understand, then we will create one complete project end to end. So for moment, if means for today's video, that's it from my side. And if you found this video helpful, please give the thumbs up, subscribe to TechFlow Media, and I will see you in the next part. Thank you.